All right, Pre-Calc Advanced students, we get started on the year with section 2.1. So we skip our first chapter, which is really a review of things that you guys have learned before, although you'll see also in chapter 2, which is all about functions, this also can be a little bit of what you've learned before. So we start out very simply with the definition of a function. And the purpose of these notes, as you'll go through our remote learning this year, is to give you the basics, the general idea of what we do lesson by lesson, section by section, and then synchronously in our class time we'll go through some examples, we'll do some activities that deepen the learning for each section, and you guys will see the structure play out over however long we aren't able to be in the physical classroom. So again, starting with the definition of a function f is a rule that assigns each element from a set A to, very key here, exactly one element f of x in a set B. This should say each element x from a set A to exactly one element f of x in a set B. Okay. The way you guys have probably learned functions before, at least initially from a different teacher back in your algebra classes, was inputs and outputs. So really the x turns into the f of x. The x could be classified as your input, the f of x your output. You know, other terminology that you'll see here, when we talk about x, we talk about domain, we talk about the outputs, we talk about range, and then the x would be your independent variable, and your f of x would be your dependent variable. The f of x depends on what the x is. It's basically waiting to know what the x is so we could figure out what the f of x is. That's that independent, dependent. Some of you teachers may have even drawn you this little function machine here. Where you drop the f of x into your input in the function f of x, the function f, and then out comes f of x, or your output. Okay. So different ways students have learned or visualized what a function is. How do we know something's a function? There's different ways that we can think of it algebraically, but if we're looking at a graph or thinking of it graphically, that's usually the easiest way to determine whether a relation is a function. So if you are testing for a function, as you guys have learned in the past, we will use the vertical line test. The vertical line test basically tells us if there is only exactly one element in that second set, only one output for every input. So a couple different looks at this. If we drew what would be a parabola, this would be a function. Okay, you can draw any vertical line that you draw through this will only hit this function at one spot. Okay, so this is a function. If I actually turn that parabola sideways, which is something that you guys probably haven't worked with too much because it's not a function, as you can see, I draw a vertical line through that. That vertical line crosses this function, or this relation, this graph, at two places. This is not a function. Pretty simple, we've learned it before, and now we can move on. Okay, how do we evaluate functions? You guys have learned to evaluate functions. To evaluate a function, plug in the value of the input for x evaluate using order of operations to find the output. For instance, if f of x was equal to x plus 7. And the question said evaluate f of negative 3. Okay, this could be something that we ask you. The negative 3 is taking the place of the x. This becomes our input. Where do we input it? Anywhere we see an x on this side of the equal sign. All right, probably the only place that students might go wrong here is order of operations, maybe multiplying before taking an exponent. We don't have to worry about that here. Very simple addition. And f of negative 3 would give us an output of 4. All right. A piecewise function, just like it sounds, a function basically that's separated into pieces. So a function defined by multiple subfunctions for a certain interval of inputs. All right. So a lot of times as we teach things in math, we like to think of things generally. So the way you might see a piecewise function is with f of x equaling, then we get the set of brackets that will basically define our piecewise function in each piece of the function, the subfunction. So generally speaking, you would see, all right, f of x is going to equal this function, but only when x is, let's say, less than some real number a. Okay? And again, we're thinking generally here. So anytime x is less than a, that input would be defined by this function. But it wouldn't be all inputs. We'd have maybe a different subfunction when x is greater than or equal to that real number a. Okay? More specifically, for example, we could have f of x equals 2x plus 1 when x is less than 0, or we could have f of x equaling x squared plus 8 when x is greater than or equal to 0. That would be a specific example of a piecewise function. For any input less than 0, 2x plus 1 will define its output. For any input greater than or equal to 0, any x value greater than or equal to 0, this function would define its output. Okay, and we'll get to some examples of that when we get into class time. All things you've seen before. Let's turn the page and get into, again, some more things that you've seen before. Domain and range. Okay, very simply, the domain of a function. The domain, all possible x values or inputs of a function, and the range is all possible y values or outputs of a function. All right. Now, two different ways to think about domain and range. Usually we can find domain and range. We can find domain and range. We can think of it algebraically. For instance, maybe we're given a function, 2x plus 5. And from that function, the properties of that function, we would be able to tell and know exactly what the domain and the range were. All right. Probably most easily, if we give you the graph of a function, you should very easily be able to find the domain and range. The domain would just be very simply how far left and right the graph goes, with any undefined places in between. The range would be how far up and down the graph goes, again, with thinking about if there are any undefined places in between. And even if we give you a function graphically, and you can picture the property, if we give you the function algebraically, but you can picture the function graphically, maybe that could help you, and we'll talk a little bit about all the ways we can think about a function here in a little bit. What are some things we need to consider when considering domain? Well, there are just some problem spots that we'll talk about for domains. Problems, or undefined spots, as I like to call them. If we were in the physical classroom, we'd be, discussing what type of undefined spots. And normally each year my students will come up with the two main ones that we'll see, at least in Chapter 2. And that would be, we cannot have a 0 in the denominator. That would be a problem. That would cause an undefined situation. So what that means is what we would have to do is we would exclude any inputs or any x values that would make the denominator of a function 0. We also cannot evaluate a negative number under an even root. Okay, most of the time we're thinking square root here. So if we did have a square root in a function, we would have to exclude any inputs or any x values that would create a negative number underneath that root. Those inputs would not be part of our domain. And those are really the two problem spots, and you'll see a lot of that come up in our examples during class time. Last thing we'll talk about in section 2.1, and then we'll we'll do examples of all of these when we get to class and talk through section 2.1, is the 4 ways a function can be represented. A function can be represented verbally. Very simply, a car traveling at 10 miles per hour. I could say that to you, and really that would represent a function. The algebraic representation of that function might look like this, where f of x might be representing the number of miles, the x the number of hours. Okay? Graphically, this same function might be able to be represented graphically. Maybe this is a time and distance graph. And then it can also be represented numerically. Most of the time when we talk about a numerical representation, we're talking about a table of values. Something like that, where you would create a table to give you a picture of this function. All right? Great math students, especially when we get to pre-calculus, and even as you guys are coming out of Algebra 2 Trig, where we did a lot of this work, all right, are able to make connections between the verbal, the algebraic, the graphical, and the numerical representations. Also, there are questions that are asked in math where one of these 4 ways of thinking about a function might be the easiest one to think of as you're trying to answer a question. Okay, so being given a function algebraically, but being asked a question where it might be much easier to draw or see or just think of the properties of the graph of that function, that's a really good skill that students need to have as they get to higher levels of mathematics, including our class this year. So that wraps up section 2.1. I hope you enjoyed the video, and we'll go over all of this stuff plus some more examples of this in class.